Alright, here's an example. Solve the triangle. Given one side is 3.4 feet and the hypotenuse is 7.35 feet. So I know this is a right triangle because it uses the word hypotenuse. So let's go ahead and draw ourselves a picture. It's a right triangle. I know the hypotenuse is 7.35, so I'm going to label that in. And I don't know which side this is, so I'm just going to pick one side, 3.4, and I'm just going to call it A, just cause, so that makes that alpha. I'll call this B, and then that makes this beta. Next thing we want to do is fill in our chart. So let's fill in our chart, here we go. So A, B, C, alpha, beta, gamma. We know gamma is 90 degrees, and we said the hypotenuse is 7.35. I won't write units in my chart, I'll just remember that the units are right up here. And then we said that the 3.4, we just said that was A. 3.4. Alright, so let's solve for let's see, beta. I can solve for beta because, well, I can solve for either one, can't I? But if I pick beta, I know that, well, first of all, I know I've got hypotenuse, and then in relation to beta, I've got the adjacent. So I could say that the cosine of beta, well, that's the adjacent side over the hypotenuse, so that's going to be 3.4 over 7.35. Okay? And I'll do that one in a second, but just to say I could have used alpha, because in relation to alpha I know the side opposite, so I could have just as easily said the sine of alpha is 3.4 over 7.35. Either way is whatever you like, it's fine. Alright, so let's pick up from this one right here, and now because I know the ratio, I can turn it into an inverse problem. So I can say that the inverse cosine of 3.4 over 7.35, well, that one is equal to beta. Okay, so now we can just type that right into the calculator. So inverse cosine, and before I get too far, I'm going to check my mode, and sure enough, I'm on degree. I want to be in degree. Make sure that you are in the degree mode. Alright, so this was 3.4 divided by, what was that, 7.35. Don't forget to close your parentheses now. Enter. 62.4459. So I'll round that off to, let's pick a different color here, 62.4 degrees. Okay. Alright, so now I can solve in a lot of different ways. I can solve for alpha. Let's do alpha next. So we could say, let's do alpha. Let's use this one over here. So the sine of alpha, 3.4 over 7.35. So let's do that one. Change that into an inverse sine problem. So inverse sine of 3.4 over 7.35. Let's do that one. Oops. Equals, there we go. Equals alpha. I'll let you do that yourself on your calculator. And when you do that and round it off, you get 27.6. Okay. And then you also know that if you wanted to do this as a check, alpha plus beta, you know, equals 90 degrees. Okay. So then let's find b, and we can find b lots of different ways. You could find it by a squared plus b squared equals c squared. That would be fine. That would work. Might be just a little bit more work than using a trig function, but it would work. So let's find b. Let's see. So I know beta, so I could say the sine of, let's change colors here a minute. I could say the sine of beta is opposite over hypotenuse. So the sine of beta, and beta was 62.4 degrees. And the side opposite is b. I don't know that, but that's divided by the hypotenuse, 7.35. And I'm going to multiply both sides by 7.35. And then pick up the calculator. So let's move that problem up here. 7.35 times the sine of 62.4, and that's in degrees. That's going to equal b, and I'll let you do that with your calculator yourself. And when you do that, you get 6.52. 6.52. So there it is. We've solved the triangle, and this is a great example of using inverses. The next video I'm going to do is the area using Heron's formula. So have this example handy in your notes.